Hey everyone, it's Mr. Hing. I hope you're all good and warm. What we are going to be doing today is we are carrying on with determining the equation. Today we are going to be looking at the cos, or in this video we're going to be looking at the cos graph, which is very similar to the sine graph. That's why I've only done one example. And then we're also going to be looking at a tan graph. If you see over there, we're going to be looking at this tan graph over here. And how do we actually identify what the equation is? So over here, just a quick recap, we looked at the sine graph, and what do we remember from the previous video is that we need to know at the back, basically like it being on the back of our hands, the standard form of a sine graph, cos graph, and a tan graph. We need to know what that looks like and the general shape of the standard of those standard graphs when they're not affected. Okay, and then we use the highest and lowest technique, where you say, okay, I know my original highest point of a graph, and then the graph looks like it's been shifted, so you check and you put the low and the highest points of the shifted graph, and then you see what is the difference, or how has it moved, and then that is how you find out your letter Q and therefore your equation. Okay, so let's have a look at our cos graph over here. Sorry, my computer's gonna lag a little bit because there's so much work on this page. But okay, let's go for it. So the question is, we need to determine the equation of this blue graph over here, and it shows us that it's a cos graph, and we just need to determine what the Q is going to be. Okay, so yeah, so remember, how does we need to know this, guys? How does a normal cos of x graph look like without anything in front of it, or without anything after it, without anything affecting it? How does the normal shape of a cos x graph look? So remember, we should know this. It starts at 1 and it will go down and it will come back up, and then the lowest point is -1. Okay, so this is very, very important, and you need to know that. So when you have that in your mind, you have a look now at this graph. I'm going to get out my laser. You have a look at this graph over here, and we're going to use the technique that I explained in the previous video. So you say, okay, in an original, I call it like an original graph, the cos x graph, when it has not been affected by anything, we are going to say we know that our highest point is 1, and we know that our lowest point is -1. Okay, and now what's going to happen is you're going to say, okay, in my graph over here, we can see that they are telling us that it has been shifted because they're asking us to calculate this Q value. And we know by now that if we have a sine of x plus Q, cos of x plus Q, and tan of x plus Q, these over here indicate that it will, whatever this value is here, it will tell you if it is shifted upwards or downwards vertically. Okay, so it's shifting upwards and downwards. That's what is, how do I say it? That's the importance and the significance of plus Q after your sine, cos, and tan. So let's have a look at what are my shifted heights and depths. So let's check the highest point of my shifted graph. The highest point is -1, and then my lowest point is going to be -3. And then remember, you ask yourself, let me get a new color. You ask yourself, what did we do to go from 1, the highest point of a graph, usually it's over here, and we are going down to -1? Well, we are minusing 2. And on this side over here, if we're going from -1 and we are going to -3, well, then we are minusing 2 again. So you can see that the graph has shifted 2 units down. Let me just show you what the original cos x graph is. So if you plug it in, it will look like this. So that in yellow is what the original standard form, without a cos x graph being affected at all, that is what a cos of x graph looks like. So you can see that each point has been shifted down 2, and what I'm trying to show you is each point has been shifted down by 2, and therefore we are correct that it has been shifted down by -2 as we worked out. So for your answer, the equation of the blue graph is going to be, let me just put it in blue, it's going to be y is equal to, so it's the cos of x, and my q value is going to be -2. So this is my final answer over here. Okay, let's have a look at determining domain, range, period, and amplitude. It is a very important every single time. So let's go and answer those together. So the domain, once again, it's from, it's going to be from and including -360 all the way through to 360. And then the range, so for the blue graph, guys, the least value or the smallest y value that exists for the blue graph, we do touch -3. So it's going to be y and the e symbol, and then it's from and including -3, and it does go through all the way to the top, and the highest point is -1. So we'll put -1 and close with a square bracket. And then the period, remember I always explain it's 360 degrees for a for sine and cos in grade 10, for sine and cos graphs. And then the amplitude, I'm just gonna teach you, use the method that I've taught throughout the playlist, throughout the series of trig graphs. So we're just gonna take the maximum value of y, so -1, minus the minimum value for y in the graph, which is -3, and divide that by 2. So -1 plus 3 gives me 2/2, and that gives me +1. Okay, remember a little cheat code for sine and cos only, not for tan, is you can also take this number in front over here. So there's an imaginary 1 at this moment, but in future you're going to see that there could be 2 cos x, and you can just say, you can just literally take 2 as your answer for amplitude. Okay, if that's easier for you. So let's move on from cos. I hope this is helpful, guys. If you're getting a bit stuck, don't hesitate to pause, rewind, and just watch it again and take notes. And also, yeah, comment if you are stuck. So now, I shouldn't have put the answer over here, but it's over here anyway. Let me leave it there. So guys, I just wanted to touch quickly on the tan of x graph when it is shifted. So guys, in this case here, again, we need to know what a standard unaffected tan graph looks like. So remember, we should know that it begins at 0, 0. So it goes up like that, and it goes down like that, and then we will have our asymptote at 90, and then it'll start from here, and then it'll go up and it goes down. So now if you use that knowledge and you see that all of a sudden the graph is now not beginning over here, but it's shifted 1 unit down and it's beginning at -1, and you'll see that it continues to do that. So that's why it's so important to have the knowledge of a normal standard form tan x graph. You'll see that it has been shifted down by 1 unit. So usually if it was just the graph of tan of x, I don't know if you can hear my cuckoo clock, sorry about that. If we are looking at the tan of x graph just like that, then we know that it's usually like that. Well, it starts there. Sorry, that was a terrible drawing. It's not like that, but it goes from here, right? From here, and then it goes from there. So now we can see that it's actually dropped down, and it's dropped down everywhere by 1 unit. So therefore, we can conclude that y is equal to tan of x and then -1, because it has been shifted down by 1 unit. So I hope that is helpful, guys. This was the second question to determine the equation of a tan graph, and it's been it's showing you here that you need to determine the q value, which means that it has shifted vertically. Right, so with all that being said, I'll check you in the next one. Please follow through and keep following on in our series. We'll be touching on amplitude, also knowing how to draw more complicated graphs, and I will eventually get to exam questions. With all that being said, guys, I'll see you in the next one.